Okay, hi everyone, welcome back to this video series for the introduction to firewalls, building a simple Linux firewall. Now that you have all the building blocks at hand, you are ready to build a simple Linux firewall. How simple? The firewall that we have in mind is designed to allow all outgoing traffic and block all incoming traffic with two exceptions. It allows incoming traffic that is part of an established connection, and it allows incoming UDP traffic on port 53. The reason why we allow this UDP traffic is because we assume that our firewall has to make DNS lookup requests and also has to accept replies to these queries. Although you can type each command in the following list manually each time you start Linux, it makes much more sense to add the commands to a script so you don't have to type each command separately. Using a script also makes it less likely that you make typing mistakes. After you've created and tested the script, go ahead and have the script run each time you start your computer. If you need more information on how to create scripts, we recommend the Linux Books for Dummies by D. Alan LeBlanc, Melanie Hoag, and Evan Bloomquist, published by Wiley Publishing. So you can see here's our script. After you have entered all the rules for the input gene, you can list them by using the IP tables -v -l input command. By using the -v option with this command, you get more verbose, another word for more detailed information. Masquerading and NAT. Linux provides two versions of NAT. Masquerading is designed for dynamic IP addresses. For example, an IP address assigned by an ISP to dial-up connection. If you have a static external IP address, then you normally use a combination of SNAT and DNAT, enabling masquerading. In most cases, you enable masquerading NAT for dynamic addresses for all outgoing traffic from your network. This is a form of source NAT, which means that your firewall changes the source address of packets. To enable masquerading, you need to enter the following IP tables command: IP tables -t, NAT -a, postering -0, pp, or so I think that's -o there, pp0 -j masquerade. Notice that you are using IP tables to modify the post routing chain of the NAT table. This means that the command is applied after the packet's address is modified, after Linux has applied routing rules, but before it leaves the computer. The command also assumes that your outgoing interface is called PPP0 and your normal interface is called ETH1. If either has a different name, you need to change the command accordingly. You can find out all the gory details about the IP tables command, as well as all other commands, by reading the main page short manual for it. To do this, simply type man IP tables in a Linux command shell. Masquerading means that NAT will be applied to all traffic that is forwarded or routed. However, you still need to specify which traffic you allow to be forwarded. The following commands allow all TCP traffic from your internal network to be forwarded to the internet, as well as all TCP traffic belonging to an established session to be returned. The example assumes that your internal interface is called ETH1 and your external interface is called PPP0. If you have other network traffic that you want to allow from your network, then you need to configure additional rules for this traffic using SNAT. Configuring source NAT or SNAT is similar to configuring masquerading. The difference is that for SNAT, your external interface must have a static IP address. The following command enables SNAT. The command also assumes that your firewall's external interface is called ETH0. If it has a different name, you need to change the command accordingly. You also need to replace xxx.xxx.xxx.xxx with the external IP address of your firewall using DNAT. Destination NAT or DNAT is used to allow incoming traffic into a network that uses NAT. For example, to make a public web server at the IP address 192.168.1.80 available to your customers, you need to use the following series of commands. The first command enables DNAT. The second command creates the required forwarding rule to allow the traffic to be processed. The commands assume that your firewall's external interface is called ETH0 and the internal interface is called ETH1. If either has a different name, you need to change the command accordingly. You also need to replace xxx.xxx.xxx.xxx with the internal IP address of your firewall. By using SNAT or DNAT, you can apply very flexible rules to incoming traffic. You can change the port of the traffic as you perform NAT. For example, you can configure outgoing traffic from one internal host to be sent out with one external IP address as its source and all other traffic with a different IP address. No matter what kind of NAT you use, remember that SNAT, DNAT and masquerading only control how NAT is performed. You need to configure corresponding forward rules to allow the traffic to be sent. Firewall GUIs, depending on which version of Linux you are using, you may have a graphical user interface or GUI-based utility to do much of the work for you. Generally, such utilities allow you to configure basic personal firewall functionality. This may be all you need, but even if you are configuring a full-fledged firewall for your network, it's a good idea to do the initial setup using a GUI and then add more rules later on. One Linux distribution that has such an interface is Red Hat Linux. With the GUI interface, you get the same configuration choices that Red Hat Linux presented during setup. You start by configuring general security settings and then you specify the particular services to which you want to grant access. To start configuring the firewall using this utility, simply run the lockit command. You'll see a screen like this one as shown in figure 14.1. Then simply follow the on-screen instructions to configure a firewall functionality. Another distribution with a GUI-based firewall setup is the SUSE firewall package included with SUSE Linux 8. You start the configuration program by selecting it on Yes to Yet Another Setup Tool menu. This starts a wizard shown in figure 14.2 that guides you through the firewall configuration. Adding proxy functionality. You can enhance your firewall functionality by adding proxy support. Adding a proxy server to your network design enhances the packet filtering and stateful inspection capabilities of your IP tables by allowing the firewall to inspect network traffic at the application layer. Our proxy server can also perform user-based authentication of network traffic. Applications that are aware of the proxy server can send network requests to it instead of sending packets directly to the target. Unfortunately, not all applications are capable of doing this neat trick. To support applications that can't use a proxy server, you have to install a piece of client software that intercepts regular network requests from an application and forwards it to the proxy server. This is often referred to as transparent proxy. Proxy capabilities for Linux are available by using two different types of proxy servers, SOCKS and Squid. SOCKS, short for SOCKS, is a proxy server currently in version 5 that can process all types of network requests. After the client forwards network requests, a SOCKS server performs an application layer inspection and then fulfills the network request. The type of processing that occurs at the SOCKS server depends on the version you are using. SOCKS specifications are defined in several RFCs, requests for comments, and several versions of SOCKS servers are available. Even Microsoft Security and Acceleration ISA server supports this protocol. Most of these SOCKS servers are commercial products, but you can use a version that's available for non-commercial purposes free of charge. You can find out more about SOCKS and where to get it and how to implement it and how to wash dirty socks at www.socks.permio.com, among other items. This site contains a list of frequently asked questions that is a good starting point for learning more about SOCKS. Squid. A more specialized type of proxy server for the Linux platform is a free bit of software known affectionately as Squid. Squid is a caching server, which means that it can accelerate internet access by keeping local copies of frequently accessed web pages and other web objects such as graphics. Most web browsers allow you to configure a Squid-based caching server as a proxy server. Squid servers generally only support web requests, which include HTTP and FTP requests that are issued by a proxy-aware client, such as a web browser. However, Squid servers can't handle other network requests, such as connections to mail servers. Several versions of Squid servers are available, some of which are free and some of which are commercial software. You can find out more about Squid and how to implement it at www.squid-hash.org. As with the case with the SOCKS website, the best starting point to learn is the FAQ section. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.